So yesterday, just recall, we were multiplying polynomials. And when we multiplied polynomials, we were using the distributive property. And whenever we did that, the most popular method that we're going to use is probably FOIL, because a lot of what we're doing is going to be binomial times binomial. So when we see special cases, there's a pattern to those special cases. Meaning that we don't have to spend a lot of time doing distribution or FOIL or anything. We can use the pattern for ease of finding our products. So if I said a plus b squared, your result will be a trinomial. And it will follow this pattern. A plus b squared really means a plus b times a plus b. Are you with me? You agree? So if I were to use FOIL, and this is the only time we're going to do this because then we're going to learn the pattern, and we'll use that instead. My first term would be what? Outside. Inside. We still write AB. And last. But what do you notice? There's two ABs. And the way that you said that, Jack, is perfect. Two ABs. So the pattern for the square of a sum is a squared plus 2ab plus b squared. So whenever you see the square of a sum, you just follow this pattern. So in example 1, we're looking at 3x plus 4 quantity squared. What is my A term? What is my B term? So if I follow this pattern, a squared would be 3x squared, which is what? 9x squared, plus 2 times a times b, which is what? Plus b squared. The result of this is a trinomial, and we call it a perfect square trinomial. Now, the goal of the pattern is to get where we don't have to write this step. I only wrote it so that you can see how we got here. Are there any questions on how I went from the pattern to this part to our answer? James?
How did you get 3x times 4?
Because 2 times a times b. 2 times my a term times my b term.
Oh, I see. Sorry. I didn't realize it was being multiplied by each other.
Right, because remember when we said, hey, we have AB here and AB here, and Jack so eloquently put, we have 2 ABs. We have 2 ABs. Okay? Any other questions? Yes. All right. Geometric application. Finding the area of a square. What do you know about squares? 4 sides are equal. So if I'm finding the area of the square, what should I do? I should square it. Thanks, Ford. If squaring something the same as multiplying it by 4? Is it the same as multiplying it by 2? No, squaring it means squaring. Multiplying it by itself. So we're going to follow the pattern. Square my first term.
49x squared.
49x squared. Plus 2 times a times b.
42x.
Plus 42x. Because 2 times 7x times 3. And then my last term. This is also a perfect square trinomial.
So is it always going to be a perfect square trinomial if we do this?
With this special case, the square of a sum will always result in a perfect square trinomial. Okay, ready to do the next part? Square of a difference is exactly like square of a sum except for one part. What part is that? The negative in the middle here. So let's see what the effect is on our pattern when that happens. If I expand this, a minus b squared would be a minus b times a minus b. First, outside. Inside. Last. Is it positive or negative? It'd be positive because a negative times a negative is positive. So then what happens? So these combine to be negative 2ab. Now, when we write this pattern, do not be alarmed because we're going to keep this positive right there because it really is the same pattern except you have to notice that the b term is negative. So it's plus 2 times a times negative b, because my b term is negative in this case, plus b squared. So what that means is this right here is a negative when I'm finished. So example 2. Here is a square of a difference. It has a square symbol and it's a subtraction sign. So which one's my a term? And what's my b term? Negative 5. So 2x squared is what? 4x squared. Plus 2 times my a term times my b term. Plus b squared, so that is. And what do we call this result? It's a perfect square trinomial. So if I find the area of this square, how do I find the area of a square? I take the side length and what do I do?
Square it.
Square it. So the square of my first term, 25x squared. Double the product of my first and second terms, negative 80x. And the square of my second term, plus 64. This is also a perfect. Okay, so this is the square of a sum, square of a difference. They work the same way. The only thing that is different is the middle term's sign, and that is decided on whether it's a sum or a difference. Okay, are you with me? Any questions before we move on? So product of a sum and difference, the first term is the same, and the second term is opposites. So let's FOIL that and see what the pattern will tell us to do. First, a squared outside, minus ab inside. Last, negative b squared minus b squared. What happens to your ab? Cancels out. So our pattern would say we would take the first term and square it, and then we would subtract the second term squared, because the middle term will cancel out. What is my first term on example 3? What is my second term? So 3x squared minus 1 squared. What is our result? 9x squared minus 1. This is called the difference of squares. Why is it called the difference of squares?
Subtraction is involved.
You're subtracting, and each term is a perfect square. So example 4, what will we have? 49x squared and what? Minus 36. How do I find the area of a rectangle? Base times height. So if I have 2x plus 8 times 2x minus 8, if I find the area, what will it be?